Hello, class. This is Mr. Parsons here. Just want to take a few minutes to talk to you about literal equations. So let's take a look at these two boxes here on the right. These two boxes are giving us examples and non-examples of what a literal equation is. So if I had to compare between our examples and non-examples, we can say that literal equations have more than one variable. Okay, so looking at this example here, we can make a general statement about literal equations. Literal equations has more than one variable. And when we're thinking about literal equations, we don't necessarily want to think about solving equation. You want to rearrange the equation so that the desired variable is on one side of the equal sign by itself. And so there are many different examples of literal equations like slope-intercept form, the Pythagorean theorem, even in science, the formula for density. All of those are examples of literal equations. So let's take a look here. We have for each box on the left side, it's an equation. And then on the right side, it's a literal equation. So for A, this 144 equals 4B, this is an equation. We know we want to solve for B. So to solve for B, we know we just divide both sides by 4 to get B by itself, and we get 36. This is an example of a literal equation. So we want to solve for F. So we want to get F on one side of the equal sign by itself. So just like we did on the left side, we want to just divide both sides by E so that we can get F by itself, and F equals D over E. For B, this is a two-step equation here on the left, and to solve for X, we subtract both sides by 9. All right, when we subtract both sides by 9, it gives us 91, and then we want to divide both sides by 13, and X equals 7. Well, we approach this equation right here on the right the same way. We want to get M by itself. This will also involve a two-step equation. We want to first move B over to the right side. So we subtract by B. So we get M of X equals Y minus B. Now to get M by itself, we got to get rid of X. So in order for us to do that, this represents multiplication. So we need to do division. So for M, we have M equals Y minus B over X. For C, all right, on the left side here, 360 equals 5 times 12 times H. So we want to solve for H. So when we do that, we got to first do 5 times 12. All right, 5 times 12 is going to give us 60H. All right, and so we divide both sides by 60, and H equals 6. When we look here, we got V equals L times W times H. We want to solve for H. All right, all of these represents multiplication. So to get H by itself, we just divide both sides by L and W. And when we do that, we get H equals V over L times W. For D, on the left side here, we're doing 2 times 7 plus 2n. Well, 2 times 7 is 14. So 70 equals 14 plus 2n. Okay, and then we subtract 14 on both sides. And so 56 equals 2n. And so to solve for n, we divide by 2, and n equals 28. For the right side here, we want to get k by itself. So we're rearranging this formula or this equation. So we want to subtract both sides by mj. So we got h minus mj equals 2k. And to get k by itself, we divide both sides by 2. And so k equals h minus mj over 2. For E, we want to solve for X. So we want to go ahead and move 2 over to the other side. So this means division. So in order for me to get rid of the 2, I have to do the inverse of division, which is multiplication. When I multiply both sides by 75 by 2, that gives me 150. For the right side, T equals Q over R, and I want to solve for Q. So similar to the left side here, I want to move R to the left side by doing the inverse of division, which is multiplication. So I multiply both sides by R, and Q equals R times T. For F, all right, I want to go ahead and solve for C. All right, so I want to move 44 to the other side, so I'm going to subtract 44 on both sides. So 169 minus 44 gives me 25. And now I want to solve for C. I have C squared here, and I got to get rid of the squared. So if I think about the inverse of squared, that's going to be square root. So if I do the square root of c squared, that's going to cancel out the square. And then I want to also do the square root of 5. So remember perfect square. So the square root of 25 is saying what number multiplied by itself gives me 25, and that's going to be 5. So c equals 5. All right, I want to do the same thing for here. I want to get x by itself. So the first thing I want to do is I want to move y squared over to the right side. So I'm going to subtract. So it's going to be x squared equals z squared minus y squared. But this is x squared. I just want to get x. So to get x, I have to do the inverse of square, which is the square root. And whatever you do on one side, you have to do on the other. So x equals the square root of z squared minus y squared. And so let's look at these here. All right. So I want to go ahead and get rid of t. Not get rid of t. I want t on one side of the equal sign by itself. So in order for me to do that, I got to get rid of p and r. I got to move that to the left side of the equal sign. So these means multiplication, p times r times t. So in order for me to get rid of p and r, I have to do the inverse of multiplication, which is division. So I divide both sides by pr, and t equals I over pr. All right, for number 2, I want to get y by itself. So the first thing I need to do is move 8x over to the right side. So I'm going to subtract. So it's going to give me 4y equals negative 8x minus 12. Now, in order for me to get y by itself, I got to divide both sides by 4. So when I divide by both sides by 4, then y equals negative 2x minus 3. All right, for number 3, I got to solve for c. So the first thing I need to do is I need to move m over to the left side. M times c squared, so that's multiplication. So to get rid of m, I have to do the inverse, which is division. So I got c squared equals e over m. But this is c squared. I need to get c. So I need to get rid of that square, and I need to do the square root. So c equals the square root over e over m. All right. Number 4, ab plus cd equals e. I want to get a by itself. So the first thing I want to do is move CD over to the right side. I'm going to subtract. So AB equals E minus CD. Now I want to get A by itself. So in order for me to do that, I divide both sides by A. Divide both sides by B. And when I divide both sides by B, I get A equals E minus CD over B. So if I compare literal equations with just equation one variable we've been doing, well, the similarities is we still use inverse operations to isolate a variable. The differences is with literal equations, you have variables in your solution. All right, you got more than one variable. You're not actually solving the literal equation. You're just rearranging the equation so your desired variable is on one side of the equal sign by itself. Now let's look at these applications here. All right, the formula of a perimeter of a rectangle. We want to solve for W. So in order for us to solve for W, I got to first move 2L to the other side. So I'm going to subtract. So it's going to give me P minus 2L. And then I want to get rid of 2. So then I want to divide both sides by 2. And W is going to equals to P minus 2L divided by 2. Now that I have this formula, all right, I want to use this to solve. So if my perimeter is 244, my length is 59, then I just want to substitute. All right, so I'm going to do 244 for P and 59 for L. So that's going to give me 244 minus 2 times 59 over 2. 2 times 59 gives me 118. So 244 minus 118 gives me 126. And 126 divided by 2 gives me 63 inches. For this one, I got the formula here, converting Celsius to Fahrenheit. I want to get C by itself. So the first thing I need to do, I need to move 32 over to the left side. So I'm going to subtract. I got F minus 32 equals 9/5 C. Now I want to get rid of 9/5 and move it over to the left side. So this is saying 9/5 times C. So to get rid of 9/5, I have to divide by 9/5. But this is a fraction. So remember, when we divide by a fraction, it's the same thing as multiplying by its reciprocal. So the reciprocal of 9/5 is going to be 5/9. So to move it over to the left side, I'm going to multiply by 5/9. So therefore, my equation is going to be C equals 5/9 times F minus 32. Using this equation here, all right, if I have 95 degrees Fahrenheit and I want to know what that is in Celsius, I do 95 minus 32, all right, which is 63. And if I do 63 times 5/9, that's going to give me 315 over 9. And 9 goes into 315 35 times. So in Celsius, it'll be 35 degrees. For number 8, all right, this is the formula of the volume of the cube, all right, and we want to solve for h. We want to get h by itself. Well, in order for us to get h by itself, let us first go ahead and get rid of the 1/3, because that's 1/3 times b times h. So when we want to get rid of the 1/3, we divide by 1/3. When we divide by 1/3, we multiply by the reciprocal. So the reciprocal of 1/3 is 3, all right? So then it's 3 times v equals b times h, all right? And now to get h by itself, I got to get rid of this b. So I divide both sides by b, and so I got 3v over b. That's the equation. And it says here, Mr. Trill tells his students the value of two variables are 2,198 centimeters squared and 314 centimeters, 2,198 centimeters cubed and 314 centimeters squared. How can we determine the value of each given in this information? Well, you can look at this and kind of tell if it's cubed, you know you're talking about volume here, all right? Because if you look at number 8, you got the volume of a cube and the area of a base. So volume always in cubic units. Squared always represent your area, all right? So the area is in squared, whereas the volume is cubed. So that's one way that you can really determine as far as your volume and your area in this particular problem, okay? So just to recap here, looking at literal equations. With literal equations, you don't want to think about necessarily solving the equation. With literal equations, you're really just rearranging your equation so that you can get the variable that you want on one side of the equal sign by itself, still by using the process of inverse operations. So I hope this helps with our understanding of literal equations.